calculating the pH of acids. And here again is another calculation. What is the pH of 0.00200 molar CH2ClCOOH? COOH, again, it's an organic acid, CH2Cl. This is chloroacetic acid. You don't have to know the name, it's fine, but anyhow, that's what this is. And the Ka is given to us 1.4 times 10 to the negative 3. So again, as usual, we're going to go ahead and start with writing out our equation. So here's the chloroacetic acid dissociating to give you hydronium ion and Cl2ClCO minus, that's the acetate ion. Now you can write plus H2O over here if you want to. You don't have to because it's not part of our calculations. It's not part of our equilibrium. It's not part of Ka calculation. So you don't have to. So I'm avoiding it. But for balancing of an equation, you will need it because this H2O here gives you the hydronium ion. Okay, but that's okay if you don't want to write it. I'll be fine with this. So the initial concentration is 0.002. You don't have to write the other two zeros over here because that's just not, it's for accuracy, but later on we can work on our significant figures, so we don't have to write it out, okay, if you don't want to. Again, you can see that I try to save time if possible. And then of course our initial concentrations here are 0 and 0. So the change then is minus X for the acid and then plus X for hydronium and plus X for the acetate. For equilibrium concentration is 0.002 minus X and then of course X and X over here. So our Ka then is equal to 1.4 times 10 to the negative 3, which is equal to X and then X divided by 0.002 minus X. Okay, so before I go on forward, we're going to figure out whether we need to ignore X or not. Okay, because in some cases you can ignore it, some cases you can't. So from now onwards, we're going to do this little quick check, okay, on the side, and those will be the quick check for X. All right, so now I'm going to use the second method that I taught you, which is 0.002, which is the molarity of the acid and divided by the Ka of the acid. So that's what we're doing here, and our answer is 1.4. And 1.4 is definitely less than 100, okay, which means that we cannot ignore X. Sorry, we have to do the quadratic method. Again, remember, if this value was more than 100, then we can ignore X, okay? So which means that we got to work this out, which means that 1.4 times 10 to the negative 3 is equal to X squared and 0.002 minus X, and then 1.4 times 10 to the negative 3 is, then multiply all of that by 0.002 minus X, and this is all equal to X squared. And then open everything up, multiply everything, and this is what you should get. X squared plus 1.4 times 10 to the negative 3, X minus 2.8 times 10 to the negative 6, and this is all equal to 0. So once you have this, then you have to set up your quadratic equation, which is X is equal to minus B plus minus, and that's B squared minus 4AC divided by 2A. Okay, it's a little bit long, but you get used to it after a while. So our A, B, C are coming from our equation, of course. So our A value comes from the X squared, and our B value comes from the X, and our C value comes from the number that's left behind. Okay, and so you plug in all the numbers. So minus 1.4, please do not forget your charges. Okay, and so this plus minus and then the square root. So B squared is 1.4 times 10 to the negative 3 squared minus 4, and then A is 1. There's no number in front of X squared, so that's 1. And then C, don't forget the charge, minus 2.8 times 10 to the negative 6. Okay, so that is our square root, and this is all divided by 2 times 1 because A is 1. So hopefully you should get the X value of 1.1 times 10 to the negative 3. You will get two numbers, and by now you know that you can ignore the negative number because you can't have negative concentrations. X is equal to the concentration of hydronium ion concentration as it is over here. So then you take, you find the pH by finding the negative log of 1.1, 10 to the negative 3, which is 2.96. Okay, so there's a little bit more involved. If you cannot ignore x, then you have to use the quadratic equation. Okay, so it's a little bit more involved. Otherwise, straightforward calculation.